Welcome back. Let's look at some problems from section 10.4 from web work. Problem 1. Find the area enclosed by the curve r equals 4 sine theta. Alright, so we don't know the picture, so let's first draw the picture. So r is 4 sine theta. Use the following theta values. You see the standard theta values and find the corresponding r. Using this, we have using these points, you draw a curve. So notice this curve looks like it gets repeated. Notice at 7 pi by 6 you have negative. 7 pi by 6 corresponds to 1 pi by 6. So this point corresponds to the same point offered by pi over 6. So from 0 to pi, from angle 0 to angle pi, you go through this circle once. And again, when you start on negative, on the third and fourth quadrants for angle, you go over this again. So in other words, the same picture is repeated twice. So to find the area of this region, you don't need to go from 0 to 2 pi. You need to go from 0 to pi because that alone gives you the same curve. So area of the enclosed region is given by the curve when theta is between 0 and pi. So what is the formula for area? Area is integral 0 to pi r squared over 2 d theta. What was r? R was 4 sine theta. So you're looking at r squared, that is 16 sine squared theta over 2 d theta. Reducing this gives you 8 sine squared theta. Sine squared itself by trigonometric identity is 1 minus cosine 2 theta over 2. That 2 reduces the 8, gives you a 4. Get the 4 outside, take the integral of 1, that's theta, integral of cosine is sine, with 2 theta gives me over 2 here. Limits of integration are 0 to pi. Now evaluate it at pi. Notice sine 2 pi is going to be 0, sine 0 is going to be 0, theta equals 0 is going to be 0. So the only term that survives is pi, 4 pi. 4 pi is the area of the curve. Next. So find the area of the shaded region. You are looking at the polar curve r equals 4 plus 3 sine theta. Alright, so that's the curve they are telling us. So what about this? This until here. Alright, let's figure out what the picture is. 4 plus 3 sine theta. They are asking us to figure out this. This point corresponds to angle negative pi over 2. This point corresponds to angle pi over 2. Now, theta is between negative pi over 2 to pi over 2. So you see, you could have said 3 pi over 2, but that's not the way to go because you start from a lower end. So that's why you go from negative pi over 2 to pi over 2. Negative pi over 2 to pi over 2, r squared over 2 d theta. R being 4 plus 3 sine theta. You are squaring it. Use complete square formula to obtain this numerator. You are dividing by 2, so division distributes. Lastly, sine squared is 1 minus cosine of twice angle over 2. Alright, so simplifying all of this is standard stuff. You take integration and evaluate it at the limits. Eventually, I should get 41 pi over 4. The rest, well, cosine pi by 2 negative, they are 0. Sine pi and negative pi is 0. So let's see, 41 pi over 4. Correct. Next. Find the area of the shaded region where the polar curve is given by r equals sine 4 theta. All right. So r equals sine 4 theta. Looks like there are what? 8 petals? Yes. So you want to find area of one petal. This looks like angle 0 radians until angle pi over 4 radians. Okay. Let's check. Right. Angle 0 radians to angle pi over 4 radians. So theta is between 0 to pi over 4. 0 to pi over 4 r squared over 2. R is sine 4 theta, so r squared is sine squared 4 theta. Sine squared, you use the twice angle formula. Trigonometric identity 1 minus cosine 8 theta over 2. So there is a 2 already, and that's what makes it a 4. When you integrate, don't forget, well, we've got the 4 out, 1 over 4 out. Integration of 1 is theta. Integration of cosine is simply sine, but with that 8, I have a division by 8. Apply limits of integration. Sine 2 pi is 0, sine 0 is 0, 0. Only pi over 4 survives times 1 over 4. So that is a pi over 16 square units. All right. Fourth question. Find the area of one leaf or one petal of r equals 2 sine theta. So looks like you have 4 petals, you want one petal. So notice this goes from angle 0 until angle pi. You might also want to see it as twice of angle 0 to pi over 4. That's half a petal, twice of that. So either way you view it. Okay. We look from angle 0 to angle pi over 2. The curve is r is 2 sine 2 theta. All right. Area is 0 to pi over 2 r squared over 2 d theta. R itself is 2 sine 2 theta. It's square. 2 squared is say 4, but that 4 divided by 2 is a 2. And sine squared 2 theta. Sine squared itself is 1 minus cosine twice angle over 2. Notice we have taken the 2 out. That will reduce this. You're left with 1 minus cosine 4 theta integral. Okay. Integration of 1 is theta. Integral of cosine is sine. But that 4 theta tells you need to divide by 4. Apply limits of integration. You get pi over 2. Okay. Next problem. Find the exact length. 0 to pi over 3. Exact length. All right. Well, we have seen already actual length is given by, when we are given equation in polar coordinates, take square root dr d theta squared plus r squared d theta. So this is the formula. Angle goes from 0 to pi over 3 for our case, and dr d theta, derivative of this is cosine, right? 3 cosine squared plus r squared. All right. So 9 cosine squared plus 9 sine squared. Well, that is simply 1. Square root 9 is 3. So we bring the 3 out. Integral of d theta is theta with the limits of integration 0 to pi over 3. Answer is pi over 3 with a 3 outside, which gives me pi. This was a straightforward problem. Next problem. Find the area inside the larger loop and outside the smaller loop of r equals half plus cosine theta. Now this is a longish problem. Okay, so let's come to this in our next video.